Good day everyone, welcome to my channel. In this video, we will tackle about on how to solve transportation problem using three methods. These are the northwest corner point method, the least cost method, and the VAM or the Vogel approximation method. Now, transportation problem. Before we solve a transportation problem, let's first define what it is. Transportation problem, a special type of linear programming problem in finding the minimum cost distribution of a given commodity from a group of supply centers or sources to a group of receiving centers or destinations. Each source has a certain supply and demand. The cost of shipping from a source to a destination is directly proportional to the number of units shipped. There are types of transportation problem: the balance and unbalance. Balance is that the supply is equal to the demand, while the unbalance is supply is not equal to demand. To further understand, we have an example. Here is the example of a transportation problem. A company has factories at F1, F2, and F3, which supply to warehouse at W1, 2, 3, and 4. Weekly, factories' capacities are 70, 80, and 50 units respectively. Weekly, warehouse requirements are 45, 35, 70, and 50. Units shipping cost are as follows. So we have here the following cost. As we can see, we have the destination, which is the columns, and the source, which is the rows. From the rows, we have a corresponding supply, which is 70, 80, and 50. And from the column, we have the demand, which are 45, 35, 70, and 50. So we will determine the optimal distribution for this company to minimize the total shipping cost. But then, before we proceed to solving this transportation problem, we have to identify if this is a balanced or unbalanced type of transportation problem. So in order to check if this is a balance, we have to add the supply. We have 70 plus 80 plus 50, so it is equal to 200. And then the demand, we add 45 plus 35 plus 70 and plus 50, we have again 200. So we can conclude that this transportation problem is a balance. But then, if the supply and the demand is not equal, we can say it is unbalanced. So then, we will add a dummy row or dummy column in order to proceed to solve this transportation problem. Now we are in methods. So in order to solve a transportation problem, we first find the initial basic visible region. In order to find this initial basic visible region, we can use these following methods, which is the northwest corner point method, the least cost method, and the VAM or the Vogel's approximation method. With this, we can solve or find the initial basic visible region and then find the optimization of the cost. To find this, we can check this by using MODI or UV method. Now, first is the northwest corner point method. we have here the table. As we can see, I have allocated the following numbers. These are the allocated numbers. So I will explain how did I come up with this following allocated numbers. So first, we will find where is the northwest corner part. The northwest corner part is that it is the top left corner of the cost. So this is the top left. And then from the supply, we have 70. And from the demand, we have 45. So we will find the lesser value. The lesser value is 45. So we allocated 45 here. And then cancel out the 45 in the demand. Then 70 minus 45, we have a remaining of 25. And then because the demand has been satisfied, we cancel out these following cells. Next is, we again find the northwest corner part. So this is the northwest corner part. Then from the supply, we have 25. And from the demand, we have 35. So the lesser value is 25 from the supply, so cancel out. And then we allocated 25 here. And then 35 minus 25, so we have the remaining of 10. And then because the supply has been satisfied in this cell, so we cancel out these following cells. Next is, again, find the northwest corner part. So this is the northwest corner part, and then from the supply we have 80, and from the demand we have a remaining of 10. Because 10 is the lesser value, so we allocated 10 here, and then cancel out 10 here from the demand, and from the supply 80 minus 10, which is equals to 70. So because the demand has been satisfied, these following cells has been cancelled. Next is, we have 4 cells remaining. So find again the northwest corner part, and this is the northwest corner part. From the supply, we have 70 remaining, and from the demand, we have also a 70. So because it has the same value, so we will allocate 70 here, and then cancel out 70 from both. So the remaining is 0. So the supply and the demand has been satisfied. So we both cancel these following cells. And we have a last part of the cell. So we can say that this is the northwest corner part. And then from the supply, we have 50, and from the demand, we have 50. So we allocated 50 here. And then cancel out this 50 from the demand and 50 from the supply. So therefore, the following supply and demand has been satisfied. And from this, we have an allocated number, which is 45 into 2, 25 into 1, 10 into 5, 70 into 7, and 50 into 4. So we will do a solve to find the total cost from this. So from the allocated number, we have 45 into 2 multiply equals to 90, 25 into 1 equals to 25, 10 into 5 we have 50, 70 into 7 we have 490, and 50 into 4 we have 200. So we add these following numbers, we can get an answer of 855. So next method is the least cost method. So we have here the following table, and I allocated the following cells. So I will explain how did I come up with these allocated numbers. So from the word least, so we will find the least cost in the table. So I have choose number 1 because we have 2 1. So I choose this part. And then from the supply we have 70, and from the demand we have 35, and the lesser value is 35, so allocated 35 here. And then cancel 35, and 70 minus 35, we have a remaining of 35 because the demand has been satisfied. So we will cancel these following cells. Again, we find the least cost, so we have 1 here. And then from the supply we have 80, and from the demand we have 50. Because 50 is the lesser value, so we allocated 50 here, and then cancel out. And 80 minus 50, we have a remainder of 30. So because the demand has been satisfied in this column, so we cancel out these following cells. Next is again we find the least cost, which is number 2. We have 2 here, so I choose this cell. From the supply we have a remaining of 35, and from the demand we have 45. Because 35 is the lesser value, we allocated 35 here, and then cancel out from the supply. And 45 minus 35, we have a remaining of 10. So from the supply, because the supply has been satisfied, we cancel this part of the row. So again, we find the least cost. We have 2. And from the supply, we have 50. And from the demand, we have 70. So because the supply is lesser value, we allocated 50 here, and then cancel out 50, and 70 minus 50, we have a remaining of 20. Because the supply in this row has been satisfied, so we cancel out this part of the cell. Next is we have 2 remaining. The least cost is 6. So from the supply we have a 30 remaining, and from the demand we have 10. Because 10 is the lesser value, we allocated 10 here, and then cancel out this 10, and 30 minus 10, we have a remaining of 20. So because the demand has been satisfied in this column, so we cancel out this part. And we have a last part, which is the 7, because from the demand and the supply, we have a remaining of 20, so cancel out. And then we allocated 20 here, and because the supply and the demand has been satisfied, so we cancel out this following. And now we can see that the supply and the demand has been satisfied. So we come up with these allocated numbers. First, we have here a 35 into 2, 35 into 1, 10 into 6, 20 into 7, 50 into 1, and 50 into 2. So we solve this by multiplying and adding the following allocated numbers. So 35 into 2 is equals to 70. 35 into 1, we have 35. 10 into 6, we have 60. 20 into 7, we have 140. 50 into 1, we have 50. And 50 into 2, we have 100. So we add these following numbers. We can have an answer of 455 cost. And now another method to solve the transportation problem, which is we have VAM, or the Vogel's approximation method. And now the VAM. So as we can see, we have allocated the number here. So I will explain how did I come up with these allocated numbers. And we can see also the row difference and column difference. With this, we can use this VAM method. So, to find the row difference, we first, in the first row, we find the least value. The least value is 1. The next is 2. So we subtract this 2. So the row difference is 1. In the next row, we have 1 and 5. So the row difference is 4. Next is the 2 and 3. The row difference is 1. So we have here the answer. Next is the column difference. To find the column difference, so we have find the least in the column 2 and 3. The column difference we have 1, then 1 and 5. The column difference is equals to 4. Then 2 and 5. The column difference is 3. And 1 and 2, the column difference is 1. So after we find the row difference and the column difference, we will choose the maximum value. The maximum value is 4. So we choose this 4. And it is in the row 2. After, in the row 2, we choose the least value. The least value is 1. So from the supply we have 80 and from the demand we have 50. We find the lesser value, which is 50. So we allocated 50 here and then cancel out, and 80 minus 50 is equals the remaining of 30. Because the demand has been satisfied, we cancel out these following cells. Then, do the same operation. We find the row difference and the column difference. So we have here this. I already answered out. So, from this, we find the maximum value. The maximum value is 3. So, we choose 3 here. And then 3 from the column 2. So, the least value here is 1. So, from the supply we have 70 and from the demand we have 35. 35 is the lesser value, so we allocated 35 here. And then cancel out from the demand. 70 minus 35. So, the remaining is 35. Because the demand has been satisfied, so we cancel out these following cells. And then, next is the third row and third column. So, from the same process, we find the maximum value. And the maximum value is number 3. 3 from the first row. So, we find the least value. We have 2 here. And then, from 2, we have supply of 35 and demand is 45. So, 35 is the lesser value. So, we located 35 here. And then, cancel out from the supply. 45 minus 35. We have the remaining of 10. And because the supply has been satisfied, so we cancel out these following cells. And then the next, we find the row difference and the column difference. So we have here, I already solved. And then we find the maximum value. The maximum value is 5 in the third column. So, in the third column, we have the the least cost is number 2. So from the supply we have 50, and from the demand we have 70. Because 50 is the lesser value, we allocated 50 here and then cancel out 70 minus 50. The remaining is 20. And because the supply in the third row has been satisfied, so it has been satisfied. And as we can see, we have 2 cells that is not cancelled. So we just find the least cost, and the least cost is 6. So 30 from the supply and the demand is 10. Since the demand is lesser value, we allocated 10 here and then cancel out 10. 30 minus 10, we have the remaining of 20. And because the demand has been satisfied, we cancel out this cell. And the remaining is 7. And then from the supply, we have the 20. And the demand is also 20. So we allocated 20 here. And then cancel out both demand and supply. So then the supply and the demand has been all satisfied. And now we can see the allocated number, which is 35 into 2, 35 into 1, 10 into 6, 20 into 7, 50 into 1, and 50 into 2. And then we calculate the total cost of this VAM. So 35 into 2, we have 70. And then 35 into 1 equals to 35. 10 into 6, we have 60. 20 into 7, we have 140. 50 into 1 is equals to 50. 50 into 2 is 100. So if we add these following numbers, we can get a 455, the same as the least cost method. We have also 455. And now we are in the MODI or UV method. In this method, we can check if we can reduce the total cost of shipping. So I have here the solution, and I will explain how did I come up with this. So in finding the UV method, we have a formula. UI plus VJ is equals to CIJ. UI means the rows, and then VJ means the column. So from this M plus N minus 1 is equals to 6 to find the allocated cells. So M is the rows, which is 3, and N is the column, plus 4 minus 1. So the allocated cells is 6. So this is the 6. And then in order to find the U1, U2, U3, V1, 2, 3, 4, so we will find it by using these allocated cells. Then first, define we let U1 into 0. So we have U1 here, 0. And then V1, how did we find this V1? So from the allocated cells, we have 2 here. In order to add U1 plus V1 to come up with 2, so we will find a number that will answer 2. So we have here U1 plus V1, and U1 is 0 plus 2, so it is equals to 2. Then the V1 is equals to 2. The next allocated number is here, number 1. So number to find the V2, U1 added by V2, so 0 plus 1 is equals to 1. Next is the first column, or the second row, is U2 and V1. To find the U2, so we add a number into to make 6. So to make it 6, we have 4 plus 2. 4 plus 2 is equals to 6. And then this is 2. And then this cell is U2. We have 4, the V3. So we have to add a number in order to make it 7. So we add 3. So our V3 is 3. Next is these cells, which is 1. So from the U2 we have 4. We add negative 3 to have this cell 1. So 4 minus 3, we have 1. Sorry, this is wrong. So it is 1, not 2. This is 1, not 2. And then from this allocated cell, we have a U3, because we have V3, which is 3, we add a number to make it 2. So V3 is equals to 3. We add a number which is negative 1 to make it 2. So we have here negative 1 plus 2. These are the use roots or cells, or the allocated cells. These are the allocated cells. Next is the unallocated. So from the allocated cells, we then find the unallocated cells. These are the unallocated cells with the use of formula of PIG equals to CIG minus UI plus VJ. PIG is the penalties of the rows and the columns, and then as you can see, CIG is the allocated or the numbers. So from C13 means the the 1 is the rows, this is the row, and then the 3 is the column, because the unallocated cell is within the first row and the third column. So from CIG we have 5 here, minus the UI plus VJ. UI, the U1 is 0 plus 3, so we have a equivalent of 2. Next is the C14, or the row 1. This is the row 1 and the column 4. So C14. And then the CIG is 2. This is 2. And then the UI plus VJ 2. We have 0 minus 3. So the equivalent is 5. Next is the same process. We have the row 2 and column 2. So C22 is equals to this 5, 5, and then the U2, which is 4, plus the V2, which is 1. So we calculate equivalent is 0, and then the C, the row 3 and the column 1, this is the row 3 and column 1, the CIG is 3 minus the UI plus VJ, so our UI is -1, and then the V1 is 2. So if we calculate, we can come up with the answer of 2. Next is C32, or the row 3 and the column 2. So in the column 2 we have 8, the CIG, minus the UI plus 1. So we have UI -1, and the V2 is 1. So if we calculate, we can come up with the answer of 8. And lastly, the C column row 3 and column 4. So this is the row 3 and column 4. The CIG is 4, and then the U3 is -1, and then the V4 is -3. So if we calculate, we can come up with the answer of 8. And as we can see, we have no negative numbers. So these are the unused root cells or unallocated. If we have a negative in this part, or any number in this part, so we will use looping. But then, because it has a all positive number, so we can conclude that the conclusion is, since there is no negative evaluations, therefore the optimality is reached. It is not possible to reduce the total cost. Hence, the minimum shipping cost is, so we have here, we calculate from the allocated cells, is 35 into 2, 35 into 1, 10 into 6, 20 into 7, 50 into 1, and 50 into 2. And then we add these following numbers. So the total cost is 455. And that's all from my video. I hope you learned something. Thanks for watching.